Hello, everyone. My name is Patrick Nnoromele, and I am the division leader for research here at USS. I'm really grateful to be with you guys tonight, and we're going to go ahead and get started. It's 7:05. I would like to ask if you have any questions, just be sure to drop them into the chat. And at the end of the presentation, then we'll be able to field them. I'll be able to give you guys more perspective that's more unique to your interests. So with that, just going to go ahead and get started. Like I said before, my name is Patrick Nnoromele, and I am a neuroscience undergraduate here at the University of Texas at Dallas. I really dislike boring presentations. I'm going to be fully transparent. And so I want this workshop to be very fruitful for you guys and very impactful. Um, I've noticed that a lot of people have a lot of issues finding opportunities to get involved in research and making the most of those opportunities when they do get there. So, over the course of this presentation, I hope to provide you guys with a really accurate perspective on research and give you a decent blueprint to be successful in the laboratory setting. I do believe that time is one of the only resources that we really can't get more of, so I'm going to go ahead and get started. In media, there are so many myths and so many facts about research, but it's really hard to notice the difference between the two of them. Um, they are in TV shows, in movies, we see robots that can travel in time. We see suits that can withstand sub zero temperatures in open space. We see force fields. We see gene therapy that makes people immune to X, Y, and Z, animatronic sentient species, Netflix, Hulu, Marvel series. They're all just full of these fantastical scientific ideas. But in reality, research is not that glamorous. I would say that it's equally as cool, but it definitely doesn't involve time travel and all of these other things, at least not yet. For the most part, it looks more like this. You're going to walk in on your first day. You're probably just going to see some wooden cabinets with plastic countertops that are resistant to caustic chemicals. And you're going to see a bunch of machines that probably cost more than I've ever made in my entire life. You're going to see stacks on stacks of clear bottles that are in strange shapes and sizes, and their labels are completely unpronounceable. And it's probably going to be full of postdoctoral students who are severely sleep deprived and intensely focused on running their experiments. Um, I say all this to not show that research is boring, because I do not believe it is, but to understand that research is not as fast. Research is not as fast paced as it seems in all of these movies. Um, I would say that in a lot of movies, there's always that one nerd who, after they run into some conflict in the middle of the episode, the nerd's like, "Well, we could try combining X and Y. I mean, it's never been done before. It probably shouldn't work." And then, bada bing, bada boom, 20 minutes passes, the episode's over, and they solve the problem. But research is not that fast. Um, which leads me to the first key takeaway I would want you guys to remember from this presentation is that research is a very gradual process. It involves a lot of long hours, a lot of hard work, and at the end of the day, you're not really guaranteed for success. Um, so before we get into more of how to find opportunities for research, I just want to take a minute and explain why research is important, explain why it exists, and how it is constructed. Because it can be such an ephemeral idea. Like if somebody said, "Oh yeah, I'm a scientific researcher," most people would just be like, "Oh, that's cool," but they would have no idea what that looks like. So I'm going to give you a perspective on that super briefly, and then we're going to dive into the meat and potatoes, which is what I'm sure you guys came here to get. Research is how we progress in society. It helps us learn new things, which we can then use to help other people. It's the mechanism by which we acquire new information, and it's something that we can use to fight inequality, to improve the lives of everyone that we meet, right? Vaccines are expensive, they aren't distributed evenly across the world, so we can use research to make vaccines cheaper, or we can use research to make it so that you don't have to refrigerate vaccines so they're more accessible to people. We can also use research to launch rockets to Mars or do gene therapy. The possibilities are genuinely endless. But research in itself takes place at very unique institutions. It can take place at one of two locations, either academic institutions or private institutions. So, academic institutions involve universities and other accredited medical institutions. What makes academic institutions most different from private institutions is that you can get a degree from them. You can get your bachelor's, you can get your master's, your PhD. And these tend to be funded by grants, which I'll get more into in just a second. On the private side of things, you have clinics, pharmaceutical companies, and national research institutions. So, clinics are private practices that treat patients and use information about those patient interactions to publish new research on that particular treatment. Pharmaceutical companies, they have this very unique hybrid of business and research all in the same organization. So a lot of their research is focused on creating new chemicals, finding new treatment therapies, things of that sort. Most of their funding will come from the sale of the actual drug that they produce. And then there's national research institutions. Those are very similar to academic institutions, except they're funded directly by the government and you can't get a degree from them. So it's not like you can get a master's or a PhD from the CDC, the NIH, or the National Cancer Institute. To really understand how to be successful in the laboratory setting, we have to understand how labs work. And to do that, we have to understand how they're economically feasible. So I'm just going to go back real quick to this image right here. All of the solutions, the plastic bottles, the vaccine in the lower right, these machines in the upper left, everything in this image costs hundreds of thousands of dollars. It is ridiculous how expensive it is to get equipment for the laboratory setting and conduct meaningful experiments. The equipment in these laboratories is so expensive for two major reasons. The equipment itself has to be exponent, like so precise, in order to preserve the validity of the experiment. Um, and it's also scientifically complex. It, to make a machine that can measure the concentration of a chemical solution at like 10 to the negative 7 moles per liter, it's not something you can just turn in as your fourth grade science fair project. And that complexity is directly transferred into the manufacturing cost, which is directly transferred onto the laboratory. So the key takeaway here is that labs need funding in order to survive, in order to pay for their equipment, and in order to keep the lights on. And that key characteristic, it will change how research is done, the kind of research that is done, and the culture of the lab. So labs tend to receive money from two major ways. One is product sales, like if you're a pharmaceutical company and you're selling a product to consumers or to other businesses. They can take some of that revenue and use it to fund their research. The other way is grants. Grants are basically like scholarships. So the leader of a research laboratory, that's called the principal investigator, or the PI for short, will write basically a scholarship application to these private institutions or to these government funded institutions and say, hey, this is the research I want to do. This is how I'm going to use the money from this scholarship. And I would really appreciate if you would give it to me. And the probability of getting a grant has a lot of different factors within it, but grants are how the vast majority of researching endeavors are funded. Donations can also be kind of included, but they're not a major aspect of the funding process. In order to receive a grant, the research you have to be doing has to be innovative. It has to be something the world has never seen before. And the lab has to be well represented, right? And in order to see if a lab is successful, most people will look at the publications that that lab has produced. How many papers has that researching group published on a particular topic? And were those publications impactful in the scientific community? And then they also want to look at the relevance of the research that they're doing, right? So if you are a person working in a lab that's geared towards finding a cure for pancreatic cancer, as opposed to a researcher who works in a lab that is trying to study why white oak trees only grow well in soil pHs from 7 to 8. The cancer research is going to get much more money. It's going to get much more grants because it's going to help more people. Um, and all of these, the way that this money system is designed has a very unique impact on the environment that is within the laboratory setting. So the laboratory setting is very team oriented. Everyone in there is outstandingly competent and driven. And they're team oriented because they understand that research takes a lot of people, a lot of brains, and a lot of physical hands to conduct experiments, which means that everybody needs to be great at communication and everybody needs to be competent in the subject matter. The subject matter is usually very complex if they're doing innovative research. And once they have enough experiments, once they've done enough experiments and gathered enough data, then they can publish a paper about it in a scientific research journal, which leads us to the second key takeaway from this. Publications are absolutely the currency of research. The amount of papers that a particular lab group can publish is a direct correlation to the success of that lab. So there's three major factors in a publication, right? Um, how many publications is the lab producing? How frequently are they producing it? And what is the prestige of the journal that they're getting their papers into, right? So there are three top journals, I would say, in my own opinion: Nature, Science, Cell, which are basically the Harvard, Yale, and Stanford of research journals. And for those of you who do not know, a research journal is basically a platform that researchers can submit their papers into in order to have them featured in magazines and to really get that information out into the scientific community. And they play a very important role in the scientific community because everything in research, like I was saying before, is gradual. It's very incremental. People build off of each other. They use techniques that other people have made. So publications are how researchers will communicate with each other. So Nature, Science, and Cell, if you can get your name into one of those journals, you're kind of set. Um, Getting funding becomes exponentially easier because the grants are going to look at your lab and say, oh my gosh, this kid's got um, a nature paper, a science paper, a cell paper, whatever he's doing, it's working for him. Our money won't be wasted. But on the counter side of that, it's really hard to get into these journals because they have exponential or really high standards. So this is why it's important to do good research and why it's really important for these labs to produce publications. That's how they get funding. Research has a lot of hardships in it, but it has a lot of beauty in it too. You know, you get to pursue your curiosity, you get to ask questions and then use the techniques that you've learned to answer those questions. And when you discover something, that piece of information is something that no other human being in the history of human beings has ever known. And having that thrill of just discovering something new is insane. Um, and then when you think beyond that, the ripple effect from that discovery can have untold positive consequences for the rest of history, right? Like, even if it's something super small, like you're studying one half of a really small molecule that's involved in this particular pathway in the human body. It might not seem big now, but maybe somebody in the future is going to read your paper and then build off of that to find a cure for some disease or to help astronauts while they're working on the International Space Station, right? The physical work of research is also very entertaining. In the lab that I work in, which I'll get into later, we're always on our feet. Like I'm literally running around the lab from experiment to this other experiment, always thinking. You're always working with your hands, pipetting things. It's a lot of technical work, but it's very enjoyable. It can become mundane, but it's nice just to be doing physical work. And then as a prerequisite, for grad school and medical school. So medical school, it looks really good if you have research because it shows that you can take initiative, break down really complex topics, and be successful at it. And oftentimes it's mandatory if you're trying to apply for grad school and for some medical schools. It depends on what you're applying to. Okay, so now that I have gotten that out of the way, giving you guys a relatively accurate perspective on what research is, the best I could do without actually being in a lab yourself. This is the general overview I'm going to take for the rest of the presentation. Step one being my journey with research. Who am I? Where do I come from? And why research is important to me. I was born and raised in a super small, sleepy town in central Kentucky. I drove by maybe 3 or 4 cow farms to get to school every morning, and I loved it there. I grew up there all 18 years. Both of my parents are Nigerian immigrants who came to this country looking, as most immigrants do, for a better life for themselves and for their children, and we settled down in Kentucky. And although I loved it there, you can only drive by the same cow farm so many times. So I traveled and I wanted to come to a university that was outside of my comfort zone and outside of the community and culture that I grew up in. So I came to the University of Texas at Dallas. And it was here that I discovered my love and passion for research. So you'll see here, this is a picture of the first building that I worked in. I worked at first with a software engineering startup for the federal government. They were, oddly enough, trying to take Minecraft and implement AP chemistry and AP biology principles in a way that just by interacting with the game, you could basically learn everything that you needed to know for that subject. I was on the thought think tank side of things, making sure that they stayed accurate to the true science and chemistry. From there, I ended up working on a nanotechnology project on the other side of the building. Started working on neurological implants with some really cool metals. We were trying to find metals that wouldn't break down in the body and ultimately create basically replacement neurons and maybe a tool that we could use to help neurons regenerate themselves. And after that, I ended up working in a cancer, well, kinase biology research lab with a focus on cancer. My particular project was geared towards leukemia, and I've been working there for about a year now at the University of Texas Southwestern Medical Center. I got published for my work in nanotechnology about a year ago, and then this past spring, I was awarded the Barry Goldwater Scholarship for researching excellence, which I was super grateful and humbled to receive. So research has been progressively become this important part of my life, and I am really looking forward to pursuing this as a career. I'm hoping to become a MD PhD, which is a joint degree program where I could work both as a clinician, a physician, and also as a researcher creating cures for people. So now time for the meat and potatoes. I know a lot of you guys came here to understand where to find researching opportunities. And I know that some of you guys are undergraduates and some of you guys are postgraduates. Maybe you're taking a gap year before you go to medical school or just trying to figure out what you want to do with your life, which is perfectly fine. I want to share with you guys the opportunities that I have found as both an undergraduate and a postgraduate. So, or excuse me, for undergraduates and for postgraduates. I'm currently a junior. So, as an undergraduate, your best bet will probably be emailing people at your university. It's helpful if you are taking a course with um, a researcher that you're interested in working under. Go to their office hours, network with them, talk to them about the research they do, show a genuine passion. And then you can also send out cold emails, which I'll give you some tips on in the next slide. In terms of finding national opportunities to pursue research, I cannot stress this enough. These programs are fantastic. They're national summer research programs hosted by the federal government. They go by NSF-REU, so literally search this up on Google, and you will see a list of hundreds, and I mean hundreds, of summer-long research opportunities for undergraduates. What they look like is 10 weeks where you are matched with a PI, the leaders of the research laboratories, and you work with them for 10 weeks on a project. And then you usually have a poster presentation about what you discovered at the end of it. The benefits of these programs is that one, you can be paid about $4,000 depending on the program, to go and do research. And you don't need to have any previous experience. All you have to do is fill out the application, get your recommenders in line, and hopefully get accepted into the program. And some of these programs will actually pay for your room and board and for your flight out there. So please take advantage of these. An told advantage of these programs is that if you do one that is at your university or near your university, sometimes they will keep you on for the following semester. So you're going to, one, have the privilege of working at such a really great university, and you're also going to be able to have a more long-term impact because that summer will be really intensive, and you'll learn all the procedures that you need to do to be innovative in the laboratory setting. For those of you who, like me, were um, kind of wrecked during COVID-19 in terms of the study abroad, there are a lot of international summer research fellowships, and some of them that occur during the actual school semester that you can pursue. Most of them are located in Europe, specifically Germany and Austria. I've noticed some of them are in the Netherlands and a little bit in Sweden. If you're doing a lot of physics work, I've noticed. Then there's a lot of them in East Asia as well, and a handful in Australia, but not too many that I've noticed. Um, these are great ways to study abroad. Some of these will actually pay you to study abroad. They usually don't pay for your flights out there. They usually don't pay for your room and your board, but they're great opportunities to do something really great, put something great for your resume, and also to have some fun, enjoy, and explore the world. If you are a postgraduate, taking a gap year or just trying to figure out what you want to do with your life, there are a handful of things that I would recommend for you guys. You can apply for a master's degree um, or try to get your PhD. The process for that is a little, or the timeline for that can be a little bit complex and a little bit unique to the area that you're trying to pursue, but it generally follows this timeline, right? So you will take your GRE in the summer, then you will, during the fall, figure out what schools you want to apply to, take any subject test for the GRE that you want, submit your applications, which are usually due between October and December, and then you will wait for acceptances from January to March. And then from April all the way to May, you'll be selecting the school, traveling to that school to see where you would want to do your graduate degree. But that's generally the timeline. And of course, that's subject to change depending on the modality or the specific branch of the sciences that you're hoping to work with. You can also work in local clinics. Like I was saying before, there's a lot of really cool private practices that you can work in as an administrator and then maybe work your way in to more responsibility in the organization. You can start taking data from patient interactions, maybe publish your own paper. And a lot of these guys, if you do a local clinic if you live in the region where you graduated from university and you pursue a local clinic opportunity in that general area, you're going to be much more likely to get a position and it'll be easier for you to build your network. But though that was something I'd very much recommend. I know a lot of people who do that, and you can actually make a decent amount of money doing that. Like you can make a salary paying job, like 40,000, with benefits, depending on the clinic that you work. So I would definitely look into that. And then these last two, lab technician, researching hospitals, kind of go hand in hand. Lab technician, you're basically working as a full-time researcher. You're basically doing the same work as somebody who's trying to get their PhD or master's degree. You're working in the same lab, but you aren't pursuing a degree. You can do this in certain states without having to take any exams. You just email the PI of that particular laboratory, send them your resume, set up a meeting, say, hey, I really want to work with you. This does require a little bit of previous experience. So if you had done laboratory experience during your bachelor's degree, this is much more feasible for you. Another thing to consider is that certain states do require you to get licensed to be a lab technician. I do not believe Texas does. Um, Fact check me on that. But that is another great way to get more researching experience during a gap year or during your postgraduate career. Um, and then researching hospitals are, if you are not unable to be a lab technician, like have that title, you can also be a part-time intern at a researching hospital like UT Southwestern or any of the Big Ten, where you're basically doing the same work that a lab technician, a master's student, a PhD student would be doing, but excuse me, but you would have the title of an intern, and you might not get paid as much. So those are just things to consider, and those are the four primary things I would recommend that you would pursue if you are in that position. So I promised you guys I would talk about cold emails because I've heard so many horror stories. People was like, Patrick, man, I emailed like 28 professors a cold email. I sent a CV, I sent a transcript, and they didn't respond to a single one of them, man. Like, what's going on, man? And so I have a handful of tips that I have learned through trial and error, that I've learned by talking to my mentors, my PIs, and I would like to share them with you guys. So, in order to understand where these are coming from, you got to look at it from the perspective of the person receiving the email, right? These people get so many emails a day. They are plugged into a network that reaches across the entire globe. They're getting dozens of emails, and there are certain times where they're getting even more emails. The beginning of semesters, at the end of semesters, because sometimes these researchers are teachers at universities. So timing is everything. But you want to first keep them short. Always include your CV and your transcript, because what'll happen is you'll send an email, and then if you get a response, they'll probably just ask you for your CV and your transcript anyway. So you might as well just save yourself the extra email and include it in the original email. Little side note, a CV is different from a resume. A CV includes a list of all the relevant coursework that you have done that might be able to contribute to the laboratory setting. This is the equivalent of a resume for anything in the sciences and related research fields. So you always want to include those two. And if you can also include a cover letter depending on the application that you are um, applying for. This is the biggest one, or one of the second biggest one, I would say. You have to read the publications that the lab has produced and then tie in the work that they're doing, how you're able to contribute to that work to help them accomplish what they're trying to accomplish. Make the email relevant to the laboratory setting and be specific. Show them that you've read the publications. Don't, when you're writing these emails, there are two major red flags that I've heard about from PIs and from other leaders in a laboratory setting. So avoid these two things. Don't talk about how you've always been curious about studying neuroscience and that's why you majored in it and you really just want to pursue it more. Everybody's curious. And also, don't talk about how a family member suffered from a specific disease and that's why you want to join for a lab. Although that is a very significant experience and very relevant to you, um, these PIs that I've heard, and when they talk to me about these kinds of things, a lot of people come in with that kind of story, and it's not really a relevant predictor to see how effective you're going to be in the laboratory setting. So when you're writing these emails, you want to focus on how you can contribute to the lab and show that you've done your homework. And if they don't respond to you, it's probably because they didn't see it, not because they wanted to ignore you. Like I said, they get so many emails a day. So try again after 2 weeks. And then if they don't respond to you, maybe look for a different lab. Another technique you can do is that some some PIs don't like it when people just interview them and ask for a job. So you can ask for an informational interview. You say, hey, I read these papers. I'm really fascinated about XYZ that you're doing. I would love to spend 20 minutes just talking to you about how you got where you are, ask you questions about the research you're doing. And more than likely, they'll say yes, because everybody loves to talk about themselves. The biggest thing that I want you to take away from cold emails is that timing is absolutely everything. Do not send an email to a PI within the 2 weeks before the start of the semester and 2 weeks after the start of the semester, because they probably just won't see it. The best times to send it are during the summer or during the middle of the semester, depending on the lab. So do your homework, but remember those techniques for time. And regarding COVID, we gotta think long term, right? So getting into a laboratory this semester or next semester is going to be kind of difficult because there's so much liability in bringing somebody in, and a lot of the projects that people are working on are time sensitive. They don't want to have somebody who, especially a college student, right? Because we have a really bad rap with COVID-19. They don't want to bring somebody in who infects the entire laboratory, and then they have to shut down the lab and they can't do the work. So my recommendation is to look for opportunities in the summer. Look for those NSF opportunities that I was talking about earlier and apply for those. Those deadlines usually are from November to December. Sometimes they go into February, depending. But yeah, look for those opportunities and pursue those because those have the highest probability of coming to fruition. Okay. So next, we're just going to talk about applications. How are you going to craft your application when you are applying to be in these internships or these government funded researching opportunities? You're going to see these questions or variations of them so many times. What do you want to do? How does research fit into that? Why do you want to do research in general? And where would you like to research within their institution? It's okay if you don't know what you want to do professionally. All they really want to know is how you think ahead and make rational plans. So you need to sell your plan, be specific as possible, but be sure to include that your future plans will continue to grow and evolve as you grow and evolve as a person to show that you're open minded and you don't um, appear very closed minded. And so, because also that these questions are very stereotyped across research intern applications, um, once you get solid answers for each one of these, you can just modify them a little bit, rework them a little bit, make them unique to the application that you're applying for. And when you're applying to these applications, I would say cast your net wide, apply to maybe 10, 20 of them if you have the time, because there's no penalty if you apply to more. A couple of things um, I want to iterate when it comes to these applications, and that is specificity shows that you care. Specificity shows that you've done your research, and specificity shows that you know how to make a plan that can work. So when you're talking about what you want to do, be specific. Even if you don't know, just you don't have to decide what you're going to do for the rest of your life. Just make a plan in that moment of what you want to do um, for this application. Avoid cliches, like I was saying earlier. Don't say you've always been interested in X, Y, and Z, or that one of your family members had X disease and as a result, you really want to learn more about it. Well, although that is true, it won't be unique. And the people who review your application get tired of reading applications that are the same or have very similar stories. So if you want to stand out, find a unique story to tell. Always stay relevant. People sometimes they take the tell the story information a bit too far and they end up telling a story that doesn't really exhibit why they want to do research. And that's a red flag. Like it could have been a great story, but they're going to throw that in the garbage can because it doesn't answer the question. And then the last two, weaving a thread is a bit of an advanced technique. Throughout all of your questions, you want to bring it back to the same central point. Like, I want to pursue cancer research because to me, I love understanding how cells can go wrong. To me, it's like the final frontier in science. People talk about space and how that's the final frontier, but to me, I think there are more mysteries inside of the human body than there are in the world around us. Like find something that's very unique to you and weave your application around that central thread. And people are going to see, oh, this guy's dedicated. He's thought about this a lot to the point where his thoughts are so well developed. He keeps expressing his interests in different ways. It shows that you're multifaceted and very unique. The last thing, do your research. Please, please do your research. When they ask you, what labs would you like to work in? Take the time to go onto the website, look at the individual PIs, read the abstracts at the very least of their papers, and then talk about how what you want to do is going to complement what they're doing in the lab. That's going to show that you actually care about getting the opportunity, and it's going to increase your chances of getting that opportunity. So once you get into the lab, this is excuse me, generally the progression you're going to see. For those of you who have worked in the lab, this progression will seem a little nostalgic. For those of you who have not, this is going to be very interesting. When you walk in on the first day, they're going to give you a bunch of grunt work. I can almost guarantee you. You're going to be mixing solutions together. You're going to be pouring gels. You're going to be cleaning. You're going to be the person who's putting the data into the Excel charts. And yes, that may not be the most fun, but if you do that well, then you can move on to step two, which is grunt work with increased responsibility and complexity. So then they'll say, oh, well, he does all of these things well. He's very dependable. Or she is doing all of these things well. She's very dependable. Let's teach her how to culture cells. Let's teach her how to purify DNA. Let's let her write this specific code in the process, in the experimenting process. And once you have built credibility within the laboratory, and once you've built the foundation of tools and skills, you kind of understand the experiments, what things are used for, then you might be able to shadow and assist certain graduate students and postdocs in their projects. So they'll say, oh man, I need somebody to run a PCR for me. Oh, well, I did that over the past couple months. I'll be glad to do it for you. And they'll be like, oh, great. Thank you so much for taking this off my hand. I hate doing these because I've done hundreds of them. I really appreciate it. And by doing this kind of things, you can sometimes work your way onto getting your name into a publication, but more on that later. And then once you've built a lot of credibility, people know that you're dependable, people know that you can do the work, you can go to your PI and say, I would like to pursue a project. And to do that, you're going to go read the literature, ask a question that hasn't been answered by that literature, and use all these tools that you've accumulated to solve it. So, just a couple of things. All these steps are cumulative. So, even if you're pursuing an independent research project, you're probably going to be doing some grunt work just because you're still an intern, you're at the bottom of the totem pole. And when it comes to taking initiative, asking questions, reading the literature, it's important that you think about timing, right? So these people are very busy. Sometimes working in the lab can be very stressful. So when you're asking questions or you're asking to take on more responsibility, make sure you time it right. Don't wait for when they're doing a really unique, really intensive laboratory experiment to ask them how you can contribute more in the lab or to ask them um, about a vocabulary term that you saw in a paper you read. Just think about your timing. There are a couple other things I want to hit on here. There is a concept of confidentiality within research. Once a paper has been published, people can't publish that same finding again. So if you're working on a research project, you don't want to talk about what you're working on all that much with other people, especially in other people who are working in similar labs, because they might take your idea, do the research faster than you're doing it, publish a paper, and then everything you just worked for goes out the window. It's called getting scooped. That's the terminology they use in the research workplace. You want to avoid that as much as possible. Your goal during this whole process is to show that you take initiative, show that you're dependable, and hopefully to get published. You do that by doing a work that is going to be included on a research presentation. There's this concept of authorship inside of the presentation or inside of the publication. If you're the first author, you did most of the work. If you're the second author, you had contributing parts to it. If you're the first author, that means that you are the head of authority for the research that was done, and you can take full ownership of the work. I want you guys to understand that if you are getting into a lab for the first time, 90% of your experiments are going to fail. Like, my experiments still fail. Like, failure is the universal denominator for every single research, regardless of modality. Regardless of modality, you will fail because it's difficult to discover things nobody has ever seen before. And when it comes to showing your commitment to the lab, it's better if you underpromise and overdeliver, right? So if you say, I can only come 4 hours a week and you come six, that's a lot better than saying, I can come 8 hours a week and then still only coming six, right? When it comes to breaking down literature, I'm going to break an article down for you guys really quick here in a second, but they follow this basic architecture. So first you're going to have an abstract, which is basically a summary of the entire paper. Then you have an introduction, why they did it, what question they were trying to ask. Methods is how they found the answer to that question. Results are what they found. And then the discussion is what other questions can we ask from what we have discovered. And then at the end, there's going to be a list of references, probably anywhere from like 12 to maybe a couple dozen, sometimes over 100 articles that they reference in order to perform their research. If you're looking for papers, always use Google Scholar. It's really hard to find them on regular Google or Bing or anything like that. So Google Scholar is a database exclusively to find research literature. And you might notice you'll have to start a subscription to read some of these articles. Depending on where you are, your university might already have a subscription or have a discounted service, so be sure to look into that. And a good way to get some brownie points is to ask your PI and your lab members for research literature that you can read, because it shows initiative and it shows that you really care about the project. This is a general flow that you want to follow when you're breaking down a publication, in my opinion. People have different methods they want to use, but for me, this is the most efficient. Read the abstract in full, read the intro, skim the methods, read the results, go back to the methods, look at the references, see which ones are relevant, and then repeat the whole process. And in total, this shouldn't take more than 50 minutes, but in all actuality, once you get good at it, it's going to take you maybe 15 minutes for one paper. So with that, I'm going to go ahead and pull this up really quickly. One second. I'm not sure if you guys can see my screen, so here's what I'm going to do. I'm going to do this. Okay. So here is this paper I want to break down for you. So, okay, let's see here. Ruthenium oxide-based microelectric arrays for in vitro in vivo neural recordings. Imagine that you're reading this as someone who's never learned about this kind of type of thing before, right? So you're going to scroll down and be like, oh, this is the abstract. Okay. I'm going to work through this. I'm going to see, oh, I don't know what cytotoxicity is. Let me highlight that, write that down. Oh, I don't know what functional neurotoxicity is. Okay, I'm going to write that down. Material electrolysis, occurrence, microelectric arrays. I don't really know what that is. I'm gonna look that up. Indium tin oxide. I don't know what that is. I'm gonna look that up. You're gonna do the same thing for the introduction. Okay? And after each one of these paragraphs, you're going to write one sentence summary of what you just read. You don't have to understand every single little bit of it, but you need to understand the big picture. Do that for the abstract, do that for the introduction. Oh, I see the methods. I'm going to skip all the way down till I get to the results. Okay. Same technique for the abstract and the introduction that you're going to use on the results. You're going to read this, look for pieces of vocab you don't understand, write a one sentence summary. You're going to break down these figures, which can be exponentially helpful. And you're going to do the same thing here for every single component of the research. And then you're going to say, okay, well, I've gotten to the end of the read. Oh, that's discussion. I should go back up to the methods And that's when you want to start breaking things down. Take note of the experiments that they use in these papers that you are unfamiliar with, and you can ask your PI or your lab manager about them later. Okay, general, I'm going to perfect. Okay, hope you guys can see this. Okay, which leads me to the third takeaway. If you want to make an impact in research, you have to learn how to speak the language. The language that they use is very tedious and there's lots of long words and it's very hard to pronounce. But once you learn how to speak it, everything becomes exponentially easier. It's like when you're in a lab, it's like you're having conversations with people who are literally speaking a different language. They know words that we don't. So if you learn how to speak the language, you're able to innovate, make a serious impact, and do some really, really good work. I want to take a minute and just talk about asking for letters of recommendation really briefly because a lot of people think it's intimidating. It's really not that intimidating as long as you've been doing some good work and showing that you're dedicated to the lab. So I would recommend that you only ask after you've been there for about a semester or so. It's important that you stay professional when you're asking, like as you get into the lab, you're going to become more and more comfortable with your environment. And of course, it's good to bring a lot of positive energy and it's good to make people smile, but you don't want to be a goofball because sometimes that can come off as incompetent. So stay professional in the research lab. And when you're writing these emails, it's important to stay professional as well. One technique that I found is very helpful is to write that email, say, oh, hey, PI, Dr. Smith, um, I'm thinking about applying for this program, and I would really appreciate if you could write me a letter of recommendation. I have included a template, which is basically you wrote the letter for them, but you left a little bit of space for them to add a little bit of personal touch. I've included this template so that you get an eye feel for what they are asking for in the application. Feel free to use it or discard it as you see fit. Thank you so much for your time. And then you send it. And then more likely than not, they're going to use that template because it's a lot easier and they'll add their own personal touch. And you're much more likely to get a yes from your PI if you do a lot of the work for them. Which leads us to our last point, which I'll try to blaze through pretty quickly so that we can have enough time for questions. I am willing to stay over for a bit of time to answer any questions you guys may have. Um, Thank you guys so much for listening to me. This is something I'm very passionate about and I love to share with people. So I'm really grateful that you guys are here. Last two things I want to talk about are conferences. Conferences are basically conventions for all of the researchers across the country who are passionate in your area of research. It's a nerd fest, to put it simply. And you can go to as many as you want. Go to as many as you can. If your PI invites you to go to a conference, the answer is always yes. If you're trying to present at a conference, there are a couple things you should keep in mind. You don't want to present the same research paper multiple times at different conferences, right? It's actually frowned upon in the community. If you publish a paper, you go to one conference and you share that with them. You don't go to two conferences and do the same presentation. That's frowned upon in the community. And if you notice that your PI doesn't really want to take you to conferences, you can actually apply to go to conferences for undergraduates or gap year students, similar to the way that you apply to do these NSF REU research fellowships. Um, the only difference is that you will see a lot of the same questions, but they'll ask you a little bit about your research. So be sure that you can articulate that very efficiently. And the last thing, informational interviews. You can use these in three major modalities that I've noticed in research. One, you can use it to learn more about the researcher that you're hoping to research under. If you are working in an academic institution, chances are there's a lot of laboratories that are near your laboratory. So you can use use this technique to get more information and network with the people who are researchers on the same floor. And then you can also use this to network with people at conferences. So I would recommend that after you get your research opportunity, target the people on your floor. You want to do the research, read their publications, understand what kind of things that they're trying to discover, Then you walk in or you send them an email and you say, your work is inspirational. How did you get where you are today? Some variation of that. Would you be willing to chat over coffee for maybe 10 or 20 minutes? And more than likely, they'll say yes, because once again, people love to talk about themselves. And when you're in that conversation, you want to focus on them. You're not trying to sell yourself. You're just trying to have a conversation with them about something that you genuinely find interesting and something that they genuinely find interesting as well. And you want to make sure that you're asking relevant questions. Like go with the flow in the conversation, but if you ask relevant questions, it shows that you did your homework and that you really care. And a lot of people can be a little bit disingenuous when they do these types of things, but don't butter them up. They can see straight through that. These are very intelligent people. If you want to have a meaningful relationship or add a meaningful connection to your network, you want to be very genuine when you're doing these things. It comes from a place of genuine curiosity and genuine admiration. When it comes to research, initiative, confidence, and hard work will take you so far. Take you so far. And do your best in the researching setting to embody these to the best of your ability. With that, I will open the floor for questions. Once again, my name is Patrick Nnoromele, Patrick Nnoromele. That's my email right there. I'm the only Patrick Nnoromele on LinkedIn, so it shouldn't be too hard to find me. But I'm really grateful that you guys got the chance to listen to me talk about something I'm really passionate about. So I'm going to open the floor for questions. Open up the chat here. One moment. One moment. How did you get into your first research opportunity? From Jasmine. Okay, that's a great question. Fortunately, I was in the right place at the right time. So I was um, with a couple of friends, and we were on a pre-college kind of trip to Santa Fe, and we ended up talking to a researcher happened to work who happened to work at the university I was hoping to pursue. I was going to attend in the coming weeks. And he was like, "Oh, hey, you seem like you're really involved, and I would love for you to come work in my lab." So I was very unique. When I went to my second opportunity, that was a little bit more stereotyped. I had to send a bunch of cold emails. I got a reference from friends. So the friends that I had a couple of friends who had worked in that lab, and I was like, "Hey, who should I email in this lab?" And they were able to set me up with a really good opportunity that way. So let's see here. Hi, can you talk more about the NSC, NSF, REU application? Oh yeah, I'd love to. So the NSF REU app, actually, you know what? Or I'll try to find a way to send you guys a link, or I'll drop a link into the USS group chat again with the master list that has it. Basically, it's a 10-week researching opportunity in the middle of summer where you're matched with a particular lab, and these are located at universities across the nation. So UT Southwestern, um, Harvard, Yale, Stanford, even some of the smaller colleges, um, like more private colleges. They're just about everywhere if you look for them, and they'll usually have an application portal on their university website that you can go to, or you can search it up on their university website. You'll find the link to the application. Usually, those applications open October and December, so keep your eyes out there. Sometimes they don't update them from the previous cycle, so be sure to check those sites fairly regularly. You'll submit your application. It'll usually be some variation of those 4 questions that I talked about earlier, and you'll hear responses back later in the spring semester. And you will have a certain amount of time to accept or deny. I would recommend that you cast your net wide. And yeah, it was a really fruitful experience for me. it's actually kind of a cohort experience because you're matched with people from across the world who are working at that university who applied for that same fellowship, and you guys get to like build this kind of community, do cool research. It's really a lot of fun. So yeah, be sure to look into that. Let's see here. Oh, what is my favorite aspect of research? That is a really hard question. Very simple question, a very good question. The thrill of discovering something that nobody's ever known before, like no other human being, is so like invigorating, you know? And the other thing I would say is that research is very unique in that you're always innovating. Like with medicine, once you become a surgeon, right? Like you've learned the protocols, you've learned the procedures, you've learned X, Y, and Z. There's only so many different things that you can do with what you know. And you're rarely required to innovate. Of course, you're required to innovate on a day to day basis to understand that particular patient. But generally, the solutions that you have are stereotyped. And there's not a lot of room for innovation per se, because a lot of these things have already been innovated. People already know how to do certain procedures in certain situations. But in research, you're always trying to take your tools and combine them in a way that nobody's ever combined them before to create something the world has never seen. And so that kind of like, I love solving problems. So that creative process is one of my favorite aspects. What's something that can really make us stand out? Writing well. If you have no research experience, but you know how to tell a story and you are know how to convince people that research is what you need in order to help you get where you need to go, people are going to love reading your application and people are going to understand where you're coming from. So if you want to stand out, learn how to tell a story really effectively and learn how to weave a thread through your application. Um, I would also say that having some previous research experience does help, but it's not required. I ended up applying for my summer research fellowship, excuse me, my summer research fellowship before I had really gotten any research experience whatsoever. I was just working at that software Minecraft thing, not really doing anything in a real laboratory. But I was able to get that position because I had great mentors who helped me write great stories. Is one term of research enough to apply for summer research programs? Yes. Yes. You don't even need experience. Just like I said, learn how to tell a story. Show that you're really involved. If you're a postgrad student looking for an entry level biomedical research opportunity with no prior research, how can you stand out in your application process? Capitalize on what you have. So let's say you were in your undergraduate career, you volunteered with X curricular, extracurricular, this organization, something else. Focus on what you have and then find a way to tie that into how you're going to be effective in a laboratory setting. That would be my best recommendation for you. You can also apply for more administrative positions at those organizations, things that don't really require you to have too much knowledge about biomedical research, and then work your way into the laboratory by taking on more responsibility and building credibility in the organization. How do you know if you are confident enough to join a research team? I got my associates from a community college and transferred to UTD this year, but I don't feel like I didn't have anything. Got my associates, UTD. You know, the best way to really become confident in terms of communicating in a laboratory setting is to ask questions before you start giving answers, right? Because a question is never arrogant. If you're in a research setting and you're doing all the work at home, you're going home every night, you're reading these research papers, you're reading the literature about your particular area, and then you are coming into the laboratory setting with a little bit of knowledge, it's always better to ask first. And then once they start giving you the answers, you can use that same vocabulary to gain more confidence when you're talking about the same thing at a different time. So, in terms of knowing when you're competent, I think that's a personal confidence thing. Um, it's a really good sign if people are having conversations and you know every single word that they're saying. Like that's a really good. That's like becoming fluent in the language. So I would say to look out for that. Are there any summer stipend biomedical research for postbacalorates? With a stipend for postbacks, I'm not too certain. I haven't done too much research into that. I do know that there are some of those NSF RAUs that are not unique to undergraduates, so you might be able to find a handful that are for postbacks. Your best bet would be to work as a part-time researcher in that particular laboratory instead of going through one of these summer programs. But I would do some more research on that, and they do exist. They do exist. I'm just not sure how many. Oh yeah, William Johns brings up a really good point. A lot of the nationally government or federally funded institutions like the NIH, National Cancer Institute, the CDC, they have cool programs that you can enter during your post-bac year, which are kind of like these research scientist training type of things. You can do that. I know some of them run during the summer, some of them run through a whole semester, sometimes they even last a year, but that also might be a good way to fill your time during your gap year. In your opinion, would starting research your junior year in undergraduate or later reflect poorly on your application for medical or graduate school? No. And it depends. Well, I should qualify that no. If you are trying to pursue research for the entirety of your junior year, um, and you're really passionate about it, but maybe you haven't had the opportunity to do so otherwise, maybe you're at a university where they don't really let sophomores and freshmen enter researching labs, I would say that it's going to look great. I say that there's never really a bad time to start doing research, but just be sure that in your medical school applications, you can articulate why you joined your research lab when you did, so that it doesn't look like you were just trying to get something to put on your resume. How can we go about asking for specific clinical areas like metabolic diseases in an application? So in a lot of these applications, they're going to ask you what specific PIs you want to work under. Go on their website, find the PIs that are geared towards things like metabolic diseases, and talk about why you want to work underneath them. And chances are you're going to get matched to one of them. Do I need to have taken specific classes before I can do research? I would recommend that it depends on the laboratory. This presentation has been geared more towards STEM, not so much on the humanities side of things. Um, I would recommend that you, at least if you're going to the biomedical sciences, take biochemistry one. Biochemistry two is even better. At least take organic chemistry one or two. I did my first research experiences before I had taken organic chemistry, and I was absolutely lost. I had so much to make up for. Like I wanted to ask questions, but about the um, I knew so little about the fundamentals that it was difficult for me to learn the language. So I would recommend that you at least take uh, organic chemistry one and two and biochemistry as well. Have you started conducting your own research? If so, how did you come up with the topic? Before COVID broke out, I was about to start my own project. I had talked with my graduate student who I'd been shadowing for about a year. He was working on a very unique molecule called HSP90, which is a heat chaperone. And he said, Patrick, if you really wanted to look at this, there's this weird family of kinases that we don't really know much about. You have the tools to discover what these things do, basically to that effect. And so I went in, I read a little bit, I read some of the research regarding that, realized that there was a gaping hole. Nobody knew what this particular family of kinases did. And so I used the tools that I had based off of the recommendation of my PI. That's another thing. Your PI has a lot of projects that they just haven't had time to pursue. So you can just ask them. Be like, hey, if you had extra time to pursue one extra project, what would it be? And then you can use that as a starting point to build your own project. If I'm a senior graduating already in 2020, is there any way I can be eligible for a research program? I really looked and applied, and then I know that some programs are making exceptions, and I know that some programs are actually geared, well, some programs that might be able to, some programs that might have shifted their cycle um, to complement the people who are, excuse me, some programs that might have shifted their cycle to complement people who are in that particular situation. I would recommend that you do a little bit more research. I do know that some of them do exist. Excuse me. I know that they exist, but I haven't done too much research in that particular department. So if you want to reach out to me after this, I'll get more information to you, and hopefully I'll be able to be of assistance in that way. Then last question before I have to head out. Don't have another meeting, so I don't want to be too terribly late. Is there a such thing as shadowing in a biomedical research lab? Would it look good if we participate and include see for future application? Oh, okay. So there are certain labs that are facilitated by MD PhDs, people who have both a biomedical research degree, or not a biomedical research degree, they have a PhD, so they can perform really intensive research, but across many modalities. And also people who are certified to be a doctor, like a practicing clinician. And if you enter into one of those labs, you might be able to shadow that particular PI both in the clinic and do research. Um, those are very unique. There are a handful of MD PhDs, but some universities don't have them. Um, you just have to really look for it. But if you're looking for that kind of experience, I would recommend that you look for PIs that are led by MD PhDs. And it would look absolutely fantastic if you included it on your application to become a researching assistant. Um, when it comes to being a researching assistant, you really want to have as much experience as possible. So thank you guys so much. This is this has been great. I love sharing with the things that I've learned. Of course, I didn't go over everything. So if you guys have questions, email me, and if I don't know the answer, I will find it and I will get it to you. But thank you guys so much for coming out, and I'm going to have an
Yeah.
amazing. Oh, go
Sorry,
ahead.
I just wanted to cut in. So Zoom automatically takes attendance, so you don't have to fill out the member points form. If you have questions, just put it in our GroupMe chat or our Slack channel. Patrick actually has his own dedicated channel to answer questions. So yeah, thank you guys for coming.